Great. Thank you all very much. We're going to continue the climate change session. I have great pleasure in introducing Mofa Islam. Mofa is one of the staff that we were able to recruit under FaNSI. He's come to us from Bangladesh via New Zealand, Scotland and Nottingham, with an original background in agricultural extension, but a very broad skill set in both qualitative and quantitative methods. He's also, I'm pleased to say, the program leader for NRI's relatively new MSc in transformative change for sustainable development, soon to be renamed MSc in Global Sustainable Development. And Mofa's going to be speaking on climate change and farmer-herder conflict in Nigeria. Thank you very much.
Thank you. Thank you, John. Well, let me first admit that I'm a little bit nervous to talk about Nigeria in a room full of Nigerians. And I'm not Nigerian myself. Trust me, what I'm going to talk about is based on data. So if there is anything that doesn't make sense, please don't shoot the messenger. It's the data, it's not me. Okay. Right, so why bother about this farmer-herder conflict? Well, like many of you, my background is basically in agriculture and food security. But then I became interested in conflict just after the publication of SOFI in 2017. And in that report, several UN organizations jointly identified conflict as one of the biggest threats to global food security. So I thought, okay, why not working on this aspect? And there are many types of conflict, as you know, the world is suffering from right now. But one of the conflicts that I'm going to talk about today is farmer-herder conflicts. And it's particularly been a problem in sub-Saharan African countries, particularly in the Sahelian countries. And who are the farmers? So the farmers are settled agriculturists, and the herders are they're nomadic or semi-nomadic pastoralists. And according to an estimate of African Union, there are 268 million of them in the African continent, although I have noticed that the numbers actually differ in different reports. These farmers and herders have historically coexisted relatively peacefully. However, there has been surge in conflicts, particularly violent conflicts, and these conflicts are getting deadlier day by day. So the question then obviously is, why are they fighting? What exactly are the reasons? I checked the literature, and the predominant view in the empirical literature is environmental scarcity. So the idea is, as I have tried to show this, here, that's the main argument, that there has been a scarcity of productive natural resources like land, water, grassland, because of various factors. As a result of that, there has been competition between different groups for these natural resources. The pastoralists, as a result of this scarcity, sometimes are excluded, sometimes they voluntarily migrate to different areas into communities who are not very ready to welcome them. And these communities not always share the same ethnicity or religious beliefs with them, leading to tensions and conflicts. So that's the predominant explanation. There is another route, apparently, which I have defined as deprivation-driven farmer-herder conflict. It's mainly about poverty, lack of opportunities and employment, and alternative livelihoods and things like that. So that's the predominant explanation in the literature. However, there has been a recent trend in the literature that are challenging these views. They're saying that, well, the resource scarcity view is too simplistic, it's much more complex than that. Particularly, a group of scholars are pointing to political economy. Some are even talking about it's not resource scarcity, it's the resource abundance that can actually be the source of conflict. Others are saying there has been a conflict economy, so there are incentives for some actors to keep this conflict alive for their political gains or personal interests. So these views are also there. Now, the question I am asking is, given everything, politics, weak institutions, lack of opportunities, can we still say that climate change plays a role? That is the question I have explored, and I'm going to share that with you today. Now, you might be wondering that why we need to bother about whether climate change causes farmer-herder conflict or not. Well, the reason is very simple. As you have heard from several speakers, climate change is perhaps one of the biggest crises that the world is facing right now. However, not everyone buys into it. For example, a recent survey by Pew Research Center found that 14% US adults don't believe there is anything called climate change. Another survey by Ipsos, you know Ipsos Mori, found that climate skepticism has actually grown in the world. It's now around 37%. So given this situation, those of us who believe in climate change need to produce robust evidence that, well, there is a reason, there is a valid empirical reason, right? So, driven by this motive, I explored whether climate change really had any effect on farmer-herder conflict by using examples of Nigeria, okay? For this research, we collected data. We tried to create a panel data set from different sources. The conflict data came from a well-respected global database. It's called Armed Conflicts Location Event, or ACLED database. Climate change data came from the Climate Research Unit of the University of East Anglia. This is also a globally respected data set. And now they have CRU time series data version 4.07. So they have monthly data from 1901 through to 2022. So that's the latest version of data that I extracted from their database. Because the scarcity literature talks about natural resources, so I collected data on vegetation index from NASA's Earth database, and also land use and land use data from University of Maryland Global Land Use and Land Change database. This data actually was given to me by Truly. So Truly is here. She helped me get this data. And I also tried to collect data on socioeconomic variables, but it's very difficult to find this kind of socioeconomic data, particularly at the local level. So I used some proxy data sets. Some of these data were about distance of different local government units from critical infrastructure, valuable natural resources, as you can see. For example, diamond, gold, gem, petroleum, etc., and distant from coastal areas, distant from notable roads and things like that as a proxy indicator of socioeconomic development. So these are the data we put together, and the data runs from 1998 all the way through to 2023. So it's a longitudinal data on 774 local government units, or LGS, in Nigeria. So it's a massive data set. So LGA and time was our unit of analysis. 774 LGA. We had quarterly data for each year. That gave us roughly a sample size of around 80,000 observations. So that's the data set we created. And then we applied panel data methods to test the effect of climate change on two outcome variables. One is the likelihood of conflict occurrence, coded as 0.1, dummy variable, economists call it, and conflict frequency, or count, number of conflicts per LGA. So these were our two outcome variables. In our models, we had two types of model. One is the model with the variables I have showed you before, and another model where we have used what economists call lag variables. So there are two types of lags, spatial lag and temporal lag. So I'm going to explain you soon what these things mean. We created separate models for different climate change indicators. In one model, we used temperature and precipitation anomalies. In another model, we used drought index as an indicator of climate change. We also checked the robustness of these models through alternative methods to triangulate our findings. So these were the analytical strategies that we applied in our research. Okay, so I'm sorry that I have to show you a little bit of what these models look like. And this is the only slide, by the way, where I'm going to show this to you. So that's our outcome variable, conflict occurrence or conflict count per LGA. That's the intercept. That's climate change for LGA I at time t. This is time variant control, right? That's time invariant control. These are unobserved heterogeneities across LGS, which are constant over time. Then we have idiosyncratic error. So that's the model. However, in model 2, we added two lag variables. One is a spatial lag, another is temporal lag. And the reason will be obvious as we proceed. So these are the models we used. And before I share the results of this modeling, let me take you through some descriptive results. So let's start with conflict. What the situation looks like. According to our data, since 1998 through to 2023, there were 655 farmer-herder conflicts in Nigeria and 2,128 fatalities. There were 0 to 38 conflicts per quarter. So as I have said, the data are quarterly data. The mean was 6.5, and the highest conflict was in Q4 2022. There were 0 to 146 fatalities per quarter. So as you can see here, it's actually increasing. And towards this end, around 2020 to 2023, there has been a significant jump in farmer-herder conflicts. Okay, so now let's look into farmer-herder conflicts in spatial terms. So space-wise, what does it look like? See the dark red areas, that's where multiple conflicts happened, more than one conflict. Light red areas, only one conflict happened. And the areas that are not red, yeah, that's where no conflict happened. So as we can see, out of 774 local government areas in Nigeria, only 257 or 1/3 LGS are affected by conflicts, not all of them. So it gives a sort of an opportunity for us to do a kind of what we call case control type of analysis, 0-1. So some areas have no conflict, others have conflict. So how can we utilize this variation? We also found another interesting thing, and that's where, you remember in one of the models I showed that I added a special lag variable. And this is the reason. Because as you can see, there is evidence of spillover. So conflict happened here, and that probably spilled over into the next LGA, right? And according to the rules of regression, we assume that all the units are independent, but here it's not. So there is a clear violation that they are not discrete independent units, they are connected. So we need to control for this factor, otherwise the results would be misleading. That's why we added lag variable, temporal lag variable in our model. So let's look into the descriptives of climate change. What is happening in Nigeria? Has the climate really changed? If we look into the data, that's temperature data. It ranged from around 24 to 30 degrees centigrade. So that's the temperature. However, if we look into climate change, now this is one of the things I must explain to you. In many papers, they have studied about the effect of climate change on this and that. But when I look into the data, what they have done is they have studied weather change. Because climate change is a long-term phenomenon, right? So an increase in temperature in an area does not necessarily indicate climate change, right? So it has to be long-term. So in the scientific literature, people talk about temperature anomalies, rainfall anomalies as evidence of climate change. And how do we do that? We compare the mean with the historical average. In the CRU data, the base of the historical average was 1961 to 1990. So the anomaly means the deviation of the mean from that historical average. When we look into that, we see that temperature in Nigeria has actually increased by 0.5 to 1.5 degrees centigrade, which actually matches very well with other reports globally. Even the IPCC report talks about these historical changes in the last 100 years. In terms of precipitation, there is not really evidence of much change. As you can see here, it's almost like a straight line along zero, so which is not much has changed in terms of precipitation. And in terms of drought, this variable was created by a combination of temperature, precipitation, and also some location-specific other factors, I believe. In terms of drought as well, we see that there has been slight increase. So when this index becomes negative, it indicates drought. And when this index increases, it becomes wetter, right? So as we can see that some regions of Nigeria has become drier, right? But not hugely. So there is evidence in terms of temporal consideration that climate has actually changed in Nigeria, particularly temperature. Especially if we look into these graphs that I have created, maps, sorry. These are the historically hotter regions of Nigeria. Northeast, and also south-south, and then southeast. So these are the regions with higher temperature historically. But if we look into temperature change, what do we see here? Temperature hasn't changed much in these areas, actually. It has changed here, right? So the historically hotter regions, yeah, the temperature hasn't changed much. In terms of precipitation as well, this is very interesting again. So the northeastern side has seen some more precipitation compared to other areas. In terms of drought anomaly, there is no evidence of much change. There is no clear pattern, as you can see. However, the northwest seems to have gone slightly drier here, as you can see. But obviously, it doesn't look very significant. Now, so what these things mean? We have seen climate change, we have seen conflict. Now, what happens when we put these things together? So to show that, I have overlaid the conflict data on the climate data. And as you can see, so these are the pattern of conflicts, farmer-herder conflicts. We see these are the historical cattle grazing routes in Nigeria. We see a lot of conflicts here. It's close to Maiduguri, yeah, Maiduguri. Please correct me if I'm wrong, yeah. And this is the north-central region. We see lots of conflicts there. But interestingly, there are a lot of conflicts here as well. So it's south-south and southeast, and also southwest, yes, right? These are the areas where temperature has increased, as I have shown you, right? But these are not the hottest parts of Nigeria. The hottest regions are here, right? Which means that if we put climate data and conflict data together, from a visual look, the data doesn't support the theory of scarcity and movement of pastoralists into hotter areas, right? Because this is the region where historically pastoralists have lived. Okay? So if there was a positive correlation between conflict and climate change, we would have expected, we would not have expected a lot of conflicts around these areas, right? So I have no idea what actually explains this finding. However, what we can infer that there were more conflict in hotter areas, yeah, and more conflict in areas where precipitation has increased. Now, that was the visual evidence. How about we look for statistical evidence? So when I did a scatter plot, try to fit a regression line between these two variables, we see that this is statistically significant. All these three graphs are saying that the more temperature anomaly increases, the more there is conflicts, right? So this is statistical evidence. However, we have to remember that this is a bivariate analysis. So the question then is, can we still find this relationship when we control for the other factors, other confounding variables, like vegetation, for example, like local economy, for example? So that's what we can find from our modeling result. So that's the result of our first model. The outcome variable here is conflict occurrence. So it's the binary outcome we are after. And for that, the model we ran is logistic regression, of course, which is good for binary outcome variables. And these are the two models for which I showed you the equations, right? So model 2 is where we have control for our temporal and spatial lags, okay? So what do we see? These are the coefficients of temperature anomaly. This is precipitation anomaly, okay? And we see both are significant. Now, in logistic regression, the coefficients cannot be directly interpreted. So we have to take the exponentiation of the coefficients and then deduct 1 from them to get the rate of change or elasticity. And what do we see here? We see that what we call odds ratio in economics, we see that kept other factors constant, ceteris paribus, 1 unit or 1 degree centigrade increase in temperature anomaly increases the likelihood of conflict occurrence by 43% to 41%. So when you control for the spatial and temporal lag, we see a 2% decline, but it's not huge. In terms of precipitation anomaly, we see that for every 1 centimeter increase in precipitation, the likelihood of conflict increases by 27 to 26%, right? Interestingly, if we look at the role of the control variables, here, we perhaps see the evidence of the role of political economy here, particularly the theory of resource abundance. So there is more conflict, likelihood of conflict in areas close to petroleum reserves, for example. So this is an interesting finding, and there is no clear guideline in the literature that why this is happening, right? And over in all the models, we see the same result happening. In the other model, instead of temperature and precipitation anomaly, we use drought as an indicator of climate change, drought anomaly. However, we don't find any statistically significant evidence here. Now, the other outcome variable, number of conflicts per LGA. So what does our model tell us? It's almost identical, very similar result, as you can see. So that's what we call the count model, where we are not only modeling the likelihood of conflict, but also the number of conflicts, right? And we use a negative binomial model instead of a Poisson model. Poisson model also handles it very well, but we had an over-dispersed data. So out of 80,000 observations, we had only 655 non-zero values, which is, in economics, we call it over-dispersed data with a lot of zeros. And for this kind of data, negative binomial model works better. So what do we see? We see that for every 1 unit increase in temperature, conflict number increases by 39 to 42%. And for precipitation anomaly, it's around 27%. So that's the result. And again, for drought, we don't find any significant effect. As I said, we did robustness test because there are a lot of zeros in the data. Less than 1% of our data actually are non-zero of our outcome variable. And in statistics, it is suggested that for this kind of data, there is something called zero-inflated model, which works better, right? So we tested our findings with these alternative methods. One is called rare event logit. A lot of previous researchers have used this method. We tested that. We don't see much difference in our findings. See, it's the identical finding, which indicates that our models were robust. For the conflict frequency data, we used another alternative model. It's called zero-inflated negative binomial model, and we see similar findings, so which again proves that the models were very robust. Okay, that's my last statistical slide. So what do these findings actually mean for us, mean for Nigeria? Now we have our coefficients, we know the results. We can plot these findings into a regression curve and project into the future. That's what regression does. So according to World Bank, Nigeria is likely to experience from 2.9 degrees centigrade to 5.7 degrees centigrade increase in temperature by the year 2100. So if this is the case, what are we likely to see in Nigeria, right? So I tried to plot that into a regression line, and the results are showing that at 2.9 degrees centigrade increase, Nigeria is likely to see roughly 187% increase in farmer-herder conflict by the year 2100. So that's likelihood, that's at the lowest value. If we consider 5.7 degree increase in temperature, you see, it's roughly 471% increase, which means that thousands of more farmer-herder conflicts and hundreds of thousands of deaths, fatalities, that's what this country is likely to face, if these predictions come true. So that's what our results are telling us. Okay, so what are the take-home messages then? Well, the first take-home message is, it's a bad news for climate skeptics. Climate change, our results are clearly showing that it does matter, right? It's a serious thing. We need to consider it very, very carefully. The most important driver appears to be temperature anomaly, followed by precipitation anomaly. We find no evidence of drought anomaly on conflict. Our results do not support very well the theory of climate-driven pastoral outmigration. Probably it's suggesting more in-migration rather than out-migration, which might mean that it's a conflict of resource abundance rather than resource conflict. So we need to look into this evidence very, very carefully again. The mechanism through which climate change affects conflict is not very clear yet. If future climate projections come true, Nigeria is likely to witness thousands of more conflict, as I have said. However, we should be careful about some of these findings because of data limitations. Particularly, as I have said, there were serious lack of local level socioeconomic data. I haven't found, but if you know, please let me know, yeah, so that we can improve these models. So in the future, what we can do with Nigerian colleagues, we have been, Uche and myself have been trying to work with some Nigerian colleagues, including colleagues from the Ministry of Foreign Affairs. Probably we will try to explore how we can collect some local level socioeconomic data. That might be very, very useful. And the request we would like to extend to other colleagues. If you know anything, please let us know. So these are the key take-home messages from this research, which is still in progress. So it's still a work in progress. And thank you for your patience.
Thank you very much, Mo, for a very interesting and also sobering analysis. Now, if you have questions on this, please hold them in your heads, because the next presentation is also on the topic of conflict, and also I think has Nigerian data in it. So I'm going to go straight on to the next presentation and then have a joint question session after that. So I'd like to introduce Dr. Uche Okpara, who is again another of the appointments that was made possible by FaNSI, who is a senior fellow in climate change, conflict, and state fragility. Uche actually took his master's degree at NRI, which is something we're very proud of, and then several years later came back to us as a staff member. We're also very proud of the fact that since coming back to us, he's gained one of the very coveted and very competitive Future Leader Fellowships given by UKRI, which is going to fund his research for the next 4 years. So I'd like to introduce Uche, who will speak on thermal discomfort and conflict in the tropical drylands. Thank you very much.
Thank you, Mofa, for making my job very easy. Mofa spoke eloquently about the interconnection between climate change and conflict, but I'll be talking about one aspect of climate change that we rarely find in the literature of climate security. So I'll be speaking on thermal discomfort. How does thermal discomfort affect conflict in tropical dryland? So that is my key question. Is rising thermal discomfort experienced by dryland populations contributing to or increasing conflict? Like we all know, dryland populations are not thermally safe in a heating world. Their exposure to heat stress constitutes a public safety threat. Now, across the wider environmental peace-building literature and climate security literature, we are yet to understand this new aspect of climate change. So how does the year-to-year shift in outdoor thermal discomfort contribute to conflict? My presentation will revolve around this hypothetical model. This is how I have structured the interaction between thermal discomfort and conflict. So shortly, I'll be describing what thermal discomfort means. Okay, but in the context of my presentation, I'm looking at this pathway from thermal discomfort through to poverty, cropland changes, political instability, population pressure, and then to conflict. I'll be focusing majorly on two types of conflict: rebel conflict and communal conflict. And my presentation will revolve around three hypotheses. So I'm proposing, firstly, rising thermal discomfort, does it lead to higher conflict outcome during the wet and dry seasons? And secondly, rising dryland population pressure, does it increase the rate of violent conflict in the presence of economic, political, agricultural, and ecological factor? And then lastly, significant rise in the number of dryland population experiencing thermal discomfort, does that lead to increase in the rate of conflict? I will implore you to pay attention to this hypothetical framework, as that will guide my discussion this evening. Okay, what is thermal discomfort? Thermal discomfort conveys a sense of physical strain or psychological uneasiness or distress. And actually, it's about feeling too hot or too cold. It is a state of dissatisfaction with the thermal environment. This last text places thermal discomfort in a clearer context. The heat exchange between the human body, that is metabolic heat production, through the various activities humans undertake. In dry land, usually it is farming, fishing, pastoralism. So the heat exchange between the human body and the thermal environment and the cloth insulation usually result in what is called human thermal discomfort. So there are three things here: the metabolic heat production, the thermal environment, and the clothing insulation. So these three domains constitute what thermal discomfort actually means. And they also form the basis, for measuring thermal discomfort. Now, past research. The chart there shows the ways in which thermal discomfort has been measured over the years. So we look at indicators around air temperature, radiant temperature, air velocity, relative humidity, clothing insulation, metabolic rates, and then subjective factors like age, gender, thermal history, and other factors that has to do with subjective indicators. So across the literature, thermal discomfort has been studied in relation to all of these things you see: comfort, productivity, mental health, physical health, performance, social development, learning, cognitive skill, and well-being. And even around building design, people study thermal discomfort to enable better construction of classrooms and buildings. And the nearest scholarly effort to linking thermal discomfort to conflict has been through the heat stress or thermal stress hypothesis, or what we call the temperature, frustration, aggression, and crime thesis. And this is usually around behavioral science and psychology of social conflict. So within this hypothesis or thesis, heat is always linked to violence. So scholars have always told us that when people become uncomfortably hot, they could become more aggressive, they could begin to show signs of anxiety and rage and anger, and that could fuel conflict. So the perspective here is really about heat, but heat is not thermal discomfort. Okay, so it became a challenge to me when I began to think about heat and thermal discomfort and how to model, thermal discomfort and conflict. So I searched through the climate security literature and I discovered that the idea of thermal discomfort, particularly in dry land, has been underappreciated, and it remains an under-researched area. Why dry land? So like we all know, heat stress and thermal discomfort are among the foremost threats that climate change is driving in dry land, in tropical dry land. And like we all know as well, tropical dry land includes the warmest and most arid places on Earth. Temperature in most dry land areas are above 25 degrees centigrade. And there has been an increase in frequency, severity, and duration of heat waves, and this has led to thermal discomfort. And there are projections that thermal discomfort could create deadly events beyond the way in which climate discomfort, beyond the way in which thermal discomfort has been studied. Okay, especially beyond productivity, health, and well-being areas in which thermal discomfort has been analyzed so far. And like we all know, war and conflict are concentrated highly in many dryland areas. So my question is, if we are seeing more violence and more insecurity in many dryland regions, can we provide an interpretation, can we provide a narrative around the drivers of conflict, focusing on thermal discomfort? So in doing this, I thought to focus on the Lake Chad region. I have been studying conflict in the Lake Chad region for the past 14 years, master's, PhD, postdoc. Okay, and I understand the way in which climate change, the various parameters that Mofa has mentioned, have affected or influenced conflict in the region. But the new interest for me has been to understand the way in which the uncomfortable hot environment and the thermal discomfort implication of temperature rise in the Lake Chad region, has that in any way contributed to the rise of conflict in the region? So like we know, the Lake Chad region is located in North Central Africa. The population in the region is over 30 million, and temperature currently has been rising in the region. And indeed, temperature is rising about 1.5 times more than the global average. And there are projections that temperature in the region will increase by up to 1.6 degrees in the next 15 years. And conflict as well has been increasing. Rebel conflict and communal conflict has been increasing in the region. Now, in trying to understand the nexus of thermal discomfort and conflict, I looked for various types of data. So most of the data I used in my study relates to the data that MOFA used in studying climate change and conflict in Nigeria. But the difference here is on thermal discomfort. So conflict data revolve around rebel conflict and communal conflict, and most of the conflict on data came from different data sets: ACLED, Uppsala Conflict Data Program, Social Conflict and Data Analysis, and Global Terrorism Database. And then for thermal discomfort, what I did in terms of thermal discomfort was to derive what is called thermal discomfort index. So there is a standard formula for computing thermal discomfort in the literature. And the formula looks like this. So HX denotes humidex. So humidex is an indicator of thermal discomfort. And in the equation, you can see air temperature, and there is dew point temperature. CLO, CLO, and MET, MET, they both relate to clothing insulation and metabolic rate. Thermal discomfort is not just about climate change. It is not about heat. It's not about temperature rise. It also includes human metabolic rates as well as clothing insulation. So this was the exact equation I used in computing thermal discomfort index for the Lake Chad region over a 20-year period. The temperature data came from various sources, including the Climate Research Unit's gridded time series and data from different Met offices across the Lake Chad region. Now, clothing insulation. I struggled a lot here in trying to compute a reliable figure for clothing insulation for the Lake Chad region. Clothing insulation measure is actually measured using the CLO unit. And this captures the degree of thermal insulation provided by the clothes people wear. So every individual usually will have, a clothing insulation kind of figure. So this scholar, Gordon, produced a hypothetical number that shows how we might begin to think about clothing insulation. So usually during the summer, people wear, the clothing insulation is less resistant to heat compared to the winter period in temperate region. But in tropical region where there is higher temperature, the clothing insulation is it enables, heat. It enables release of heat somehow. So there are two key units here. For summer, Gordon suggested that we could use 0.5 to quantify clothing insulation. And then during the winter, we could use 1.0 to quantify clothing insulation. But for the Lake Chad region, where people wear more of loose-fitting, flowing robes, breathable garments, and light-colored clothing, we came up with an average of 0.8 kilo unit to quantify the clothing insulation. So typically, people in the Lake Chad region will always dress that way. Okay, so based on Gordon's suggestion, we decided to use that unit to quantify clothing insulation. There are other ways to do this. People could use surveys, to provide description of clothing insulation. But because of lack of data, we used an approximation of 0.8 kilo units. For metabolic rates, Gordon also came up with a figurative indicator that can be used to quantify activity level, metabolic rate of humans. So metabolic rate relates to the amount of energy per unit of time that a person expends to perform a certain task. So in the Lake Chad region, most of the tasks people perform revolve around farming, hunting, fishing, herding, and biking. So, and these are energy taxing activity. Metabolic rate is measured using metabolic equivalent tax. And the challenge for this study was to find an appropriate metabolic equivalent of tax for the population in the Lake Chad region. So also based on recommendation from Gordon, we came up with a MET value of approximately 6 as a measure of the metabolic rate of the population in the region. So when we computed the thermal discomfort index, we came up with this humid range and this thermal discomfort level. So for the Lake Chad region, there are a wide range of thermal discomfort level. When we plotted the findings from our analysis of thermal discomfort, we discovered that yearly average thermal discomfort for the Lake Chad region is at a level that can be described as intense. So we have intense thermal discomfort for yearly average, and seasonal trend signifies dangerous thermal discomfort during the wet season. So this is somehow puzzling in the sense that during the wet season, people tend to experience more thermal discomfort compared to the dry season. And that was quite puzzling. Now, looking at other data sets, types of data for the study, we used population data, which came from the Lake Chad Basin Commission and other sources. Poverty data came from the social and economic statistic record of each country. Political instability, we struggled with this, so we had to gather this data from newspaper articles and academic articles as well. And then data on cultivated cropland changes came from the Lake Chad Basin Commission. The Lake Chad Basin Commission is the organization in charge of managing the resources across the Lake Chad region. Our estimation procedure, similar to the estimation MOFA used, so our conflict variable was a count variable. So we used negative binomial regression. So this enabled the modeling of count of conflict events because of the over-dispersed pattern observed in the conflict data. And then in trying to model the interaction between thermal discomfort and population growth, we used multiplicative interaction procedures. And we didn't look at reciprocal interaction between thermal discomfort and conflict. So we looked only at a single pathway from thermal discomfort to conflict and not from conflict to thermal discomfort. So there was no reciprocal association in our analysis. So most of our data are sub-national time-varying data from 2000 to 2021. We didn't conduct any survey. There have been studies on thermal discomfort that have used survey. Okay, so one limitation for this study was we used a lot of approximation. Okay, and the different subjective indicators of thermal discomfort were not quantified because we didn't use survey. So we used approximation of clothing insulation and metabolic rate. Okay, this is the first finding, descriptive summary of our results. We observed that conflict during the wet season seems higher than in the dry season. Rebel conflict seems pervasive in the region, probably because it is well reported. And we observed 1,157 rebel attacks across 21 years. On average, we observed up to 55 events, rebel events, per year. And we also observed that wet season thermal discomfort level appears higher than dry season thermal discomfort. Okay, looking at our first hypothesis, still focusing on this hypothetical model. There are 4 interesting findings that relate to our first hypothesis. First is that wet season thermal discomfort and average thermal discomfort contribute positively and significantly to total rebel conflict, which is this. And the puzzle is why rebel conflict? Why thermal discomfort contributing to rebel conflict as against communal conflict? Second, wet season thermal discomfort has the probability of increasing the frequency of rebel conflict by 0.169 if we hold other variables constant. So this as well is puzzling, even though it is interesting. For every increase in average thermal discomfort, the number of yearly rebel conflict is likely to increase by 0.119. So there's a likelihood that the more there is thermal discomfort, the more we will see more of rebel conflict and not communal conflict in the region. Previous year political instability is positively associated with conflict in the current year. So across the various models, we saw that political instability was significant and positive across the Lake Chad region. Now, for hypothesis 2, population growth, does that affect conflict? We observed that a relatively strong positive and statistically significant association exists between population density 1 year prior and communal conflict. So population density, not population growth. Population growth did not give us any interesting results. So population density affected communal conflict positively and not rebel conflicts. Population density is strongly related to higher communal conflict risk, but not rebel conflict. And why is that so? From the literature, we saw that in regions where there is zero-sum struggles and greed and grievances and a history of communal conflict, population density could affect the way in which people relate and share resources. And then finally, the last hypothesis. If we have large number of dry population experiencing thermal conflict, would that lead to a rise in conflict? So here we interacted average thermal discomfort and population density. And we saw that in contrast to population density increasing or contributing to communal conflict, the interaction of prior year average thermal discomfort and population density does not contribute to rebel and communal conflict. So we noticed that where there are high number of people experiencing thermal discomfort, that would not or has not contributed to conflict, both rebel conflict and thermal conflict. Now, this finding is puzzling. The interaction between thermal discomfort and population density may probably not make rebel conflict more frequent. So taking all of this together, we discovered that our model does not support our third hypothesis. So what did we do? We thought we should convene a workshop. So we went to the region and organized the workshop. So we gathered stakeholders, policemen. We brought people together to help us interpret our model, our findings. So this policeman works across the Lake Chad region, so he understands the security issues and the climatic issues in the region. And he provided an interesting narrative on thermal discomfort and conflict interaction in the region. Now, firstly, he queried the fact that we used 21-year data. And he thought we didn't capture the historical context of the region. Okay, so for example, the idea was the heat waves and thermal discomfort of the 1970s and 1980s did not contribute to conflict. Okay, so if there were drought, massive drought and intense heat during these years, and there wasn't conflict, what could be driving the high rate of conflict currently? So this policeman told us that rising population, more heat stress experienced in recent years are amplifying conflict effects of thermal discomfort. And many of them gave us interesting narratives that are beyond climate change. For example, they said hot environments are not always conflictual, but they are seeing more of power cuts. They are seeing more of shutdown in electricity supply. And the more blackouts they experience, the more most households engage in conflict, and that sometimes spills over into communities. And all of this contributes to conflicts in different ways. Also, we are concerned about the fact that thermal discomfort is higher during the wet season compared to the dry season. So they provided narrative to help us understand why this is so. High humidity, plenty water vapor in the air, elevated temperatures during the wet season, all of this, according to the narrative, impede the evaporation of sweat. And sweating, like we know, is the body's primary means of heat dissipation. So, according to the local people, they said this sometimes leads to a sensation of increased warmth and discomfort. So they used narratives around sweating, to explain why thermal discomfort seems higher during the wet season than the dry season. So low humidity during the dry season initially leads to, feeling of coolness or cooling. So the narrative was, during the dry season, there is low humidity and there is massive release of heat compared to the wet season. And then finally, why wet seasons see more conflict? Why are there more conflicts during the wet season in the region compared to the dry season? So they gave a couple of narratives. I'll just pick one from here. Incidents usually increase when the wet season sets in. Why? Because the wet season tends to bring people together, especially around wetland areas. So wet season creates opportunities for people to look for farm work, to access farmlands, and where farmlands are now available, that might lead to conflict amongst people. All right, in conclusion, wet season thermal discomfort and yearly thermal discomfort leads to more rebel attacks and not communal conflicts. Secondly, the likelihood of conflict increasing is higher when a large number of dryland population experience thermal discomfort. So population density can lead to communal conflict and not rebel conflict. Workshop participants confirmed that rising population and more heat stress experienced by dryland population in recent years are amplifying the conflict effect of thermal discomfort. Now, in all of this, there are a couple of puzzles for me, both for the region and also for the dryland areas. Why would wet season thermal discomfort increase rebel conflict and not communal conflict? Does it mean that members of different rebel groups are more exposed to thermal discomfort compared to ordinary citizens? So if wet season thermal discomfort leads to more rebel attack, does that suggest rebel groups feel more thermally distressed, or do they use conflict as a more effective or comfortable way to express or dispel feelings of aggressivity in times of thermal discomfort? Are rebel groups more exposed to thermal discomfort? So this is a puzzle for me, and this remains an ongoing research. The next phase of this work will be to probably speak with former rebel group members to understand their perception about thermal discomfort, particularly in the Sambisa forest, the Lake Chad mountain areas and other dryland areas in the Lake Chad, where most of them have built camps. So in doing that, I'll better understand, why exactly wet season thermal discomfort has led to rebel conflict across the Lake Chad region. Thank you very much.
Thank you very much, Uche. We'll stay near the front, and thank you for that very different and very stimulating presentation on such an important topic. And just to remind ourselves, conflict is so much a factor in food insecurity that this is also a food insecurity discussion. So I'd invite questions for either of the last two speakers. I think Professor Jibreen first.
Thank you very much. These were very interesting presentations. My question is similar to both presenters. Maybe it would be good to look at other covariates. For example, from 2010, 2011, the Boko Haram activity became more prominent. And if you know the Chad Basin area, that is a place where herders go to graze their animals from several countries around the region. And because of the conflict, they had to move elsewhere, especially to central Nigeria. And that was the beginning of the conflict in Benue and other parts of southern parts of Nigeria. So it would be good to have an understanding of the shift and the migratory pattern of the nomadics. That may explain the trend we are seeing. The same thing for Dr. Opara. It's good to look at other covariates to explain some of the trends. For me, the puzzle you have, the immediate thing I will think about is, during the wet season, there is more vegetation cover for the rebels to launch their attacks. So that's why you see more of those attacks during those periods. But these are very interesting perspectives, very nice research. Thank you very much.
Yeah. Can I take a couple more questions and then you can respond? So Razak at the back.
Thank you. Thank you for the floor. Thank you for the first presentation. I have a question for the first presentation, conflict and climate change. I would like to understand, maybe it could be seen like a contribution. Is that a question? Did you try to differentiate the type of conflict? Because when we see Nigeria, geographical position, when we consider all type of conflict, it might affect your result, because when we take the example of Boko Haram, sometimes they move from Cameroon, they move from Chad. It's not only Nigeria. They are moving everywhere to that area. So the question is I was really expecting to see like a conflict between breeders and farmers, which could be really directly linked to climate change, and to see how farmers and breeders are interacting compared to your climate trend, or to your climate change trend, and also see how this climate trend involve on all those conflicts. The second concern is you talk about NDVI. And we can see also sometimes vegetation area is the refuge of rebels, where they are staying. And so to see maybe at wet season period, the second presentation was highlighting how the attack is really severe in wet season period. We see vegetation also is contributing much at this conflict trend in the area. So the vegetation also can be seen like the scarcity like vegetation. When breeders doesn't have vegetation in the area of where you highlight at the Maiduguri, right? Maiduguri zones, you see there is less conflict than the bottom part. So, and I would like to understand at that part how vegetation dynamics with the climate change trend could affect also or involve in the conflict in that area. Thank you so much.
Okay, thank you. God, everybody wants to ask a question. Can I ask both speakers to reply briefly to the points that they wish to respond to on those?
Thank you very much, Razak, for your useful comments. Well, that's actually what I'm going to do next. So looking into other type of conflicts, as far as I know, there is one paper I have found published. They looked into the correlation between Boko Haram attack and farmer-herder conflict. So there is a hypothesis in the literature that these two conflicts might have some kind of interaction. So I'm going to extend my model to look into that side of the argument as well. About that vegetation difference, yes, we can try to see the interaction effect between climate change and vegetation change, and how these two interactions actually predict conflict numbers and occurrence. So this is another thing we can do, and of course I will do that, yeah, and thank you for your suggestion.
Great, thank you. Uche, would you like to respond?
So MOFA was specific in the type of conflict he studied, farmer-herders conflict. I'm also specific in the type of conflict I studied, rebel conflict and communal conflict. However, there are evidence that suggests that different kinds of conflict in the region, electoral conflict, gender-based violence, farmer-herders conflict, communal conflict, banditry, kidnapping, all of these types of conflict and crime, they have a way of interacting, you know, and they create cascading effects across both Nigeria and the Lake Chad region. There is no clear understanding of how all the different kinds of conflict interact. And I think it's something we should be looking to doing going forward. In terms of vegetation, I mean, that also speaks to the abundance narrative, the environmental abundance narrative of yeah. So when there is abundance of vegetation or water, you know, people tend to organize and gather around such resources. And in doing that, you know, there is increase in contacts, and that might lead to struggle and competition. It's also an interesting area we'll explore further.
Great. Thank you. Can I take one from Özlem and one from Zinta and Şengün after that? So 1, 2, 3. And I'm sorry that others haven't been able. Özlem, if you want to.
Thank you. Özlem Onaran, Center of Political Economy, Governance, Finance, Accountability. This was fascinating. Both papers are really interesting. I have comments on both. So on MOFA's paper, your petroleum variable giving you the negative coefficient maybe isn't so perverse after all. It could be leading to higher inequality in that region, which then leads to higher conflict. Which brings me then to my next set of questions. You said you struggled to find variables for the socioeconomic status of the region. Household labor force surveys maybe could give you some information about income and inequality type of indicators. You would have employment, unemployment, wages, labor force participation kind of variables that requires digging into the micro survey and trying to get regional aggregates from that. And I appreciate it's not that readily available. Now, that would, of course, then lead to another issue, which would be endogeneity. I mean, you are using things that are not endogenous to conflict, which is a good thing. If you use the variables I suggest that are more about employment, income, they will be affected by your conflict variable. So your variables are actually great instruments to estimate my proposed variables of socioeconomic variable for the region in a two-stage estimation maybe. But really great paper. And same for you, Uche, very interesting paper. I kept thinking about non-linearity, and then your policeman participant to the validation workshop actually said it in more eloquent terms. Maybe one could put your TD variable, thermal discomfort, and it's square. It's a cheap way to deal with non-linearity to address, well, that gentleman's question. And whenever you showed us your beautiful theoretical framework, circular graph, I kept thinking this invites a systems estimation because all these variables are affecting each other. We, in time series, do things like vector autoregression. I haven't done it in bivariate binomial estimations, but things like seemingly unrelated regression estimation, putting those different variables all affect each other, at least with a lag in a system, just as an extension to what you have done might give some more interactions or surprises maybe. But anyway, thank you.
Zinta, yeah.
Perfect, thank you very much. Thank you for the presentations, and I don't know if my question's a bit tricky given that your findings, as you both mentioned, there's still unanswered issues or they're preliminary, but the UN Security Council last week had a debate on food security, climate change, and conflict. And very often these discussions are, can they say, oh, there's a link, we understand there's some kind of connection, but it doesn't lead to anything concrete or any specific recommendations of what governments should do. And so I'm just curious to hear your thoughts on, I mean, both of you say that there are some correlations, but you don't understand the full mechanism. You mentioned it might be, resource availability. Maybe it's something you mentioned, population density here. If you had to choose, make a recommendation to governments about, what does this mean and what they should consider in order to maintain, peace and stability in their region, what would you suggest, or where are your findings? What are they pointing at in terms of actionable policies that governments might want to consider?
Okay, could I ask both of you to respond to those, and then have Shagan and, one other person at the back, and Kola. Yeah, okay. But, yeah. Yeah, carry on, yeah.
First of all, thank you to dear colleague. That's what I was also thinking about, doing some vector autoregressive type of analysis to see, and also along with some impulse response type of analysis to see how the variables are actually influencing each other. But the problem is we have only 655 non-zero and the rest are zero. So when I want to do, for example, a vector autoregressive model, zeros cannot be converted to log, for example. So there is a problem. And the other thing is, you were right, there are some data on socioeconomic type of variables at the very micro household level. For example, I have found some data in Living Standard Measurement Survey of World Bank, but the data are only 240 something LGS, and there are 774 of them in Nigeria. See, so that's the problem. Then I have to extrapolate the data, and there will be lots of synthetic type of data, which is not really good. So that's another problem that I have faced. But yeah, these are very valid and very useful suggestions, and thank you for that. Going back to Zinta, we can actually extrapolate the data, the findings, and plot them into the map of Nigeria to predict which area is going to be more risky and prone to conflict. So these findings can be extended and visualized and presented to policymakers in Nigeria for their action. So that is possible. And we are going to do that. Yeah. Great. Thank you.
Uche, yeah, respond to those.
In terms of recommendation, what comes to mind quickly is adaptation at the nexus of climate and conflict. So you spoke extensively about focus-based financing. So I'm wondering if we could integrate adaptation at the nexus of climate and conflict within the framework of focus-based financing, to help address the double challenge of climate, conflict, and other, stressors in fragile and conflict-affected regions. So, yeah, I'm thinking about focus-based financing, integrating adaptation at the nexus of climate and conflict into such kind of mechanism. Yeah.
Great.
If you can get us forecasts, that'd be very cool.
Great. Okay. Yeah. So Shagun, and then, sorry, I can't see who you are against these lights, and then Kola. Yeah.
Hello. Yeah. This is Julius again. My question goes to the second presenter. I would like to know whether, in his review, he managed to look at some biological species, especially those that are endosemic and exomic, whether there has been a study on migratory species, especially those that are looking for hot conditions to mate, to lay eggs, or looking for food. So to look at whether there is that kind of community in the Chad area, and whether there is any decline or rise in those species that requires hot conditions. Then the first presenter may highlight or may inform me whether there was registered cases of migration and fertilities due to conflict, and possibly for fight for resources, and migration may be due to limited resources for certain group of people like herders to look for more resources beyond their jurisdiction. Thank you.
Thank you. And then,
Okay.
yeah, and then pass it the guy two rows behind you.
Okay. Thank you, Molu, Mofa, for that interesting research. And I must say, this is one of the, rigorous analysis I've seen on this debate. It has been a debate for quite a time now. Two critical variables I was trying to suggest, and one of them is the Boko Haram insurgents that actually started around 2009, which there's a study by Adelaja in Michigan State University, Adelaja and George, which actually showed that Boko Haram also drives family conflict. So that is good. You use longitudinal data from 1997, 1998, which is quite good. But the timeline of this event, I would like to see how the relationship between such event like Boko Haram and also the political angle of it and the ethno-religious aspects, which if you look at the area that are more concentrated with family conflict, you see that in Nigeria there are ethno-religious diversity. The north central middle belt area. And again, if you look at regime change or administration change in Nigeria, you can also see a political analyst may also want to look at how political regime change or administration change also correlates with this conflict, because the last administration led by President Muhammadu Buhari of Nigeria is a Fulani man, and others are also Fulani tribe. So somebody may say, oh, there's a correlation between that time when the farmer and that conflict escalated and the person in power. So it's quite very complex, and I would like to see more of these variables being controlled for in the model. And another question, which is around
we've got
the
a queue
policy
of 4,
aspect,
so, yeah.
is...
No.
Okay.
Yeah.
Okay, thank you.
Yeah. Yeah. Yep. Yeah. Okay.
Yeah, thank you. I'll keep it very short. I have to say what I'm saying now. I've lived in the North Central for at least over 40 years, and I can tell you a trend, changing trend over the last 40 years. You mentioned a very important point about cattle routes, and you have to also consider the Land Use Act and the increase in population and the use of land. If you consider these factors, it will have a big effect on your results, okay? I want to tell you categorically that the increased crisis and conflicts in this region as a result of increased use of land for crop farming and the change in Land Use Act, where some governments around these routes, cattle routes, have enacted laws that said no more cattle grazing. So all these cattle herders who are coming with arms to chase away the farmers before they will graze, because the law does not allow them to graze. And it's very obvious when you look at the cattle grazing routes that are coming around the river Benue. So people where Jibril lives rear more cattle, but they have more crisis where I live because we do more crop farming. And the only reason why a cattle herder will be allowed to farm is that if he has a gun that can chase the farmer away. Okay? If that is the reason for the crisis, yeah, the climate has an issue, has an effect, but the major crisis that we are experiencing on ground is because the initially aggregated cattle routes are now farmlands. And the state governments who own the land have enacted laws, go to Benue, go to other places, they have enacted laws that prohibit open grazing. And the herders insist they will graze, and they have to cause crisis, chase farmers away to grace.
Okay, thank you. Yeah. Amos at the back wanted to speak, I understand. Yeah, okay. Thank you, Kola.
Thank you. I'll be very, very brief. I also enjoyed your presentations, both presentations, very much. In addition to comment on the multiple confounding effects of variables that you couldn't include, I wanted to add one or even two. You might take mine as a comment, no need to respond to. Mofa, you indicated that it is not just about the intensity or magnitude, but the change, which you captured it as climate change. Uche introduced that concept of discomfort. And I was just wondering if it is not the intensity, but the rate of change, and in his case, even not the rate of change, but being able to absorb it, the response would be different. What is the role of coping strategy in here, but also resilience, absorptive, adaptive, transformative? So you might want to capture that also in your analysis. Thank you.
Okay, thank you. I think if both speakers can respond quickly to the most relevant points, and then we can wrap up or hand over to Cheryl for the official wrap up. Yeah, and apologies to those who didn't get to ask their questions.
Thank you. Really, this is really helpful. Shagun, I think this is a very important point. So we can probably do some kind of like regression discontinuity type of analysis, splitting their data from up to 2009 and after that. So that's possible in panel data. But this is a very good suggestion, and I will look into that. Thank you, Amos. This is actually what I was thinking as well after Uche's presentation, that yes, we might look into this aspect, the ability to absorb this change, that is climate change that is happening there, and at the individual level, psychological and behavioral level, and how it relates to more higher level factors. So we can think of doing some multi-level modeling kind of analysis. That is possible. So thank you all for your suggestion. And from your feedback and comments, we can understand that there is a lot of interest, and we feel really inspired. And thank you for that. We will take this research forward. Thank you.
Okay. Yeah.
Yeah, thank you as well for your interesting comments, particularly the comments around the conversion of cattle routes to farmland. I'm just wondering how we could model that. You know, how do we interpret that? How do we put that in a figure that will be captured in a model? Someone asked about biological species, whether I tried to understand the way in which thermal stress affects how biological species migrate around the Lake Chad region. I didn't focus on biological species. I focused on human dry land populations in the Lake Chad region. So the interest was to understand their thermal discomfort. In terms of coping and resilience, Mofa, we are going to probably work more on that, but also to look at the level of tolerance, and also we could look at reverse causality, trying to look at how conflict itself, affects climate change, or how conflict affects thermal discomfort. Yeah, thank you for all your interesting comments. We'll take all of that on board.
Okay.
Just one quick comment. I forgot to tell the colleague from the North Central region. In our model, we tried to control for farmland expansion. But the variable doesn't show statistically significant effect, and there may be many reasons. I am surprised too, so I will double check the data, what is going on here. And Shogun, I forgot to tell you that in our model, we control for ethnicity. So the settlements, whether they're of mixed ethnicity or not, and we didn't find any significant effect either.
Great.
Thank you.
Thank you. I'm not even going to attempt to summarize the climate change session as a whole, but just a great thanks to all four of our speakers on climate change this afternoon, and I'm going to hand over to Cheryl. Thank you all.
Thank you, John. So, well, if I remind you, we gathered together to celebrate a 4-year project, but I think we learned a lot in the last 2 days, not only from the project, but from each other. Who in the room learned something new that doesn't belong to your typical discipline? Right, yeah, I think it's been a great exposure for many people to things you wouldn't maybe even read in the newspaper if you came across, or things that you wouldn't necessarily read about. So thank you to everybody. A huge round of applause to all of you, because you've been fantastic participants. We've had excellent speakers. The FaNSI partners who have traveled here have given us so much insight. So we've had wonderful conversations around tea, lunch, and in the breaks. So thank you. As well as to all the partners and the stakeholders who were not necessarily part of the FaNSI project, but have joined us today. We've really enjoyed having you with us. So thank you. So, and to the session chairs, thank you for what you have contributed. I think the speakers contributed really new insights, challenging us, providing us with opportunities, giving us some food for thought. Listening to the NRI projects was about the celebration of what has actually been achieved through the FaNSI project itself, with lots of new insights and clearly ongoing research. So we didn't hear conclusions from absolutely every presentation. It's work that's still ongoing. The PhD students did us proud. Thank you very much for your contributions and for your boldness in standing up and presenting your oral and your posters. So, and to get feedback from an audience of this nature and such knowledgeable people is a really great investment. Thank you for investing in our PhDs. It's a really wonderful opportunity. So just in terms of summing up, there's far too much to sum up, and if you're wondering if it's going to take another half hour, no, don't worry. Just the key things that I think, and that from chatting to a few people to ask about what you would really like to hear in the conclusions, is about the complexity seems to have come up as the key element that was really tangible in many of the presentations. The centrality of food systems and the role of food systems in future development, in politics and geopolitics, in our future health, the future environment, and of course informing research directions. People came up very often. And quite interestingly, in many of the more science and technology-based papers, people were still central, and that's really one of the things that NRI does well. So thank you to bringing that, and we clearly have more work to do. The measurement issues came up quite often. And these are areas where we possibly could do a little bit more thinking about taking measures at face value and what are the kind of measures that we could use to inform, particularly what I'm interested in, the future African agenda and the global development agenda. The question of what is the truth was challenged in quite a few, of thinking, do we really know what the truth is in many of these things? So there's lots more to learn. There's lots more to learn from each other. And I think there's a lot more to learn about how we take partnerships forward. So a lot of networking has happened. We've been building on existing relationships, forming new relationships, and these are vital. It also brings home the necessity of engaging in person. So if you recognize some of the faces from virtual conversations, and you realize there's nothing better than holding somebody's hand and looking in their eyes about to really form a real relationship and partnership. So we have to find ways of doing this more often, but using technology to keep up the system. So I think together we can integrate a lot of experience. The wealth of experience has been presented, the perspectives and the different perspectives. I mean, even just the last conversation around lived experience in a particular place is really valuable. And also to challenge our worldviews, our frameworks, the tools we use, the metrics we use, the evidence we take as the norm. And then importantly, documenting the work that we do and solving today's and the future problems together, and looking for solutions that could create greater influence and greater impact. So shaping, through sharing this, we can shape the future dialogue, the future research directions, and the future for people and planet as we go forward. So thank you very much to everyone. I would really like to ask you if you could contribute to the Menti that's going on. If you want the QR code, it's here. If you would like to enter the number, it's 44923594. It's written at the top. I know it's a bit small, but maybe better on the other screens. The question is, what is your major take home from this conference? We're very curious to hear what was your main perspective, and what did you get from this session, from the two days that we've been in? So anybody, are you all right with connecting? Yeah, sure. 44923594. Got it? Do you need it for later? Are there people who are not able to connect to the Wi-Fi to add your comments? If you can just indicate and we can share it later. Otherwise, I think it's something you can do and you don't have to take home for homework. Just some insight as to what is your major take home. I'd just like, as we wrap up, perhaps for just two inputs from the floor. Any two people want to share? What is your major take home? Anyone from our partners, our visitors, our stakeholders? Thank you. Yes, they're going to give you a microphone. There we go. Thank you.
Number one is the issue of synergy. The North-South collaborative efforts need to continue. Thank you.
Oh, well, thank you. Sure. Any other major contribution from a partner, stakeholder? Yeah, there we go. Thank you.
Yeah, I think my observation is a lot has been achieved within a very short time frame of the FaNSI project. And I think that speaks to the power of focus and deliberate partnerships.
Right.
So this is the multidisciplinarity, the diversity of issues, I think have been very enlightening and enriching for me. Thank you.
Thank you, and thank you for your participation. Excellent. Okay. Yes, thank you.
In addition to what has been said, I'm very happy about the commitment and readiness of Greenwich and NRI to work with us. And we have to tighten our belt and stand with you, really. We can do more.
Wonderful. Thank you. We look forward to working with you. Okay, so just lastly, in closing, some thank yous. I've thank you for all of your participation, but this couldn't have happened without our catering team that's looked after us and provided the background for us to chatter and natter. To our fantastic team over here, our audio and visual team, and we look forward to seeing ourselves in your videos and your PowerPoints, which will be shared. Thank you so much to the two of you for working tirelessly to support that. There are three other people who have been working very hard to make this happen. And can I ask if Tony, Caroline, and Adrian can come forward, please? Come on, this way. Come, please. So thank you so much to the three of you for all the hard work that's gone behind it. Thank you very much. Thank you. So please, let's continue collaborating, communicating, encouraging each other, and working together to solve the complexity of today's world. Thank you so much.